Hello and welcome. My goal is to calculate P on my relay system, and I want to use this simple formula, and I want to calculate P multiplied with 100, so the expected result would be 314. Here you see different variations of the result, and I programmed the algorithm and the program into the C# simulation, and the expected calculation time on the relay system would be not complete 500 seconds. And here you see the correct result. So the algorithm and the program are working. So I programmed the program into the relay system and started it. And here I show you the end of the calculation. So here you see a detailed picture of the end result, and if you compare this result with the expected result, then you see this result is wrong. So the C# simulation is calculating the correct value, so the program is working, but the relay system is calculating a wrong value, so there must be a problem with the relay system. So I started the system test program. And the problem was the system test program was running in an endless loop. Okay, then I started a calculation from all values from 1 to 100, and this calculation crashed. So I played my last card and I programmed this program here into the relay system. A no operation command, then load FFFF into the accumulator and load FFFF into the instruction register, which would be an illegal opcode, and the system will stop immediately. But with this little program, I wanted to check if the memory is working properly, or if there is a problem with the accumulator register or with the instruction register. And here you see the result of this little program. These LEDs show the values stored in the accumulator, and as you can see, this is not FFFF. The instruction register showed the same wrong value. This picture here shows you the memory module of the system. Here, this Arduino is acting as a flash memory for the relay system. And these relays here are used to switch on the 24 volt used by the relay system. And now I used an oscilloscope just to check these relays here. They are not perfect. These red dots here are two defect relays. So I measured all the relays, and the following video shows you the result. So, and this yellow curve here, this is relay number 15 for data bus 15. This is my reference relay. And now I connected the second channel of the oscilloscope with one relay after the other, and all the relays are switched on at the same time. And between A and B here in this diagram are 6 milliseconds, as you can see in delta X. And when we start the measurement, then we see that most of the relays, so the first one, are switching at the same time than relay number 15. This is a little bit faster. This is also a little bit faster. This is a little bit slower, that's would say 1 milliseconds, but this is not a problem. This is a little bit faster. These are 2 milliseconds. That is not, this is a catastrophic relay. So this is the first problem. This is 1 millisecond. That's not a problem. This is as fast as number 15. That's the same. Also okay. This is the second disaster. This relay is defect. This is a little bit faster. These are 2 milliseconds. That's relatively slow. Also not close to 2 milliseconds. As we can see here in these diagrams, that at least 2 of the relays are completely defect. So it's no wonder that the relay system is not calculating the correct value. And what would be my next steps? I have to completely redesign the memory module, and instead of relays, I will use transistor-based amplifiers to amplify the 5 volts of the Arduinos to 24 volts for the relay systems.